Picture a small government office in 1969. A single room lined with humming machines the size of refrigerators. 2 computers, one at a university in Los Angeles and one 400 miles north, are about to exchange a message for the first time in history over a brand new kind of network. The engineer at the keyboard types the first 2 letters of the word, log in. The system crashes before he can finish. The first message ever sent across what would become the internet was technically just the letters L and O. It's a strange, almost anticlimactic beginning for a piece of technology that now touches nearly every part of daily life, the same infrastructure that now moves trillions of dollars, streams entertainment to billions of screens, and connects nearly every device on the planet, started with a crash and 2 letters typed by a nervous graduate student. And it's worth remembering that the network behind that crash almost didn't get funded at all. Here's what actually happened. In 1957, the Soviet Union launched Sputnik, the first artificial satellite, catching the United States completely off guard and triggering a wave of anxiety about falling behind in science and technology. In response, the Department of Defense created a new research agency, and one of its projects was a strange, largely theoretical idea: a communications network with no single central point, built so that if any part of it were destroyed, the rest could keep functioning. That project became ARPANET, and it connected its first 2 computers in that stumbling, crash-interrupted test in October 1969. The specific design behind that resilience came from a researcher named Paul Baran, who had been thinking through a genuinely unsettling Cold War problem. How would military communication survive if a single strike could knock out a centralized switching hub? His answer was packet switching, breaking information into small, independent pieces, each one capable of finding its own route across the network and reassembling at the destination, so that no single point of failure could bring the whole system down. It's a strange origin for a piece of infrastructure now mostly used for social media and video streaming, but the underlying architecture that makes the entire internet resilient today was built specifically to survive a war nobody wanted to fight. What followed was decades of quiet, unglamorous engineering. Researchers spent years developing a common language for computers to talk to each other reliably, eventually settling on a set of rules called TCP/IP, adopted as the standard in 1983. For most of the 1970s and early 1980s, the network stayed almost entirely inside universities, research labs, and military installations, understood by almost nobody outside a small technical community. The specific piece that turned this obscure research network into something the public would eventually use happened at a physics laboratory in Switzerland. In 1989, a researcher named Tim Berners-Lee proposed a way to link documents across different computers using something he called hypertext, so a scientist could click a reference and instantly pull up the referenced paper instead of hunting for it manually. His supervisor's now famous response, scrawled on the original proposal, was vague but exciting. Berners-Lee built the first web browser and web server largely on his own initiative over the following 2 years. Then came the single decision that arguably shaped everything after it. In 1993, the organization Berners-Lee worked for made the World Wide Web's core software freely available to anyone, with no royalties, no licensing fees, no restrictions on who could build on top of it. That single choice, open access instead of a patented, licensed product, is a huge part of why the web grew as fast and as wide as it did, with anyone, anywhere, able to create a website or build a browser without paying anyone for the privilege. It's worth pointing out how easily that decision could have gone the other way. Patents on foundational technology were common practice at the time, and organization funding expensive research had every conventional business reason to protect its investment rather than give it away. Other labs and companies working on similar hypertext and networking ideas around the same period did choose to license or restrict their systems, and most of those alternatives simply never spread the way the open web did. The specific choice to release the technology with no strings attached wasn't the obvious business move. It was closer to a deliberate bet that open access would create more value spread across everyone than a locked-down product ever could for one institution alone. What followed reshaped nearly every part of modern life: global commerce, instant communication, real-time financial markets, education, journalism, entertainment, and eventually the smartphone in nearly every pocket on the planet, all sit downstream of that specific decade of decisions. A Cold War fear that funded the first network, and an open, unrestricted release that let it grow into something no single company or government fully controls. Think about how far that ripples into ordinary daily life. Small businesses in one country can sell directly to customers on the opposite side of the planet without a single physical store. Anyone with a camera and an internet connection can build an audience larger than a television network used to reach. Scientific papers, medical research, and breaking news travel from one side of the world to the other in seconds instead of weeks. None of that required a government to approve it, a corporation to license it, or a single gatekeeper to grant permission, because the underlying network was built from the start to have no single owner at all. So that's what happened. Now, otherwise, picture that same small government office in 1969, except this time, the funding request for this strange, theoretical communications project gets quietly rejected. Maybe Sputnik never happens, or happens without triggering the same panic. Maybe the research agency exists, but prioritizes more conventional weapons research instead of a speculative computer network nobody in the military leadership fully understands the point of. Without that specific fear-driving urgency, the entire foundational project simply doesn't get built on the same timeline, if it gets built at all. Here's the honest complication, though, worth admitting up front. Some kind of computer networking almost certainly still emerges eventually. Businesses were already exploring ways to connect computers for internal use by the 1970s, and the underlying technology, packet switching, shared communication lines, had commercial value on its own, separate from any military application. The real question isn't whether networking eventually happens, it's whether it happens the same way, built by the same open, academically minded community, or whether it develops instead as a purely commercial product from the very beginning. This isn't purely hypothetical either. France actually built something close to this exact model decades before the web spread worldwide. A state-backed system called Minitel, launched in the early 1980s, gave millions of French households a text-based online service running through the telephone network, banking, shopping, messaging, even an early version of classified ads, years before most of the world had anything comparable. It worked well, was wildly popular domestically, and stayed almost entirely confined within France, controlled by the national telecom provider, because it was never built on an open, shared standard the rest of the world could freely adopt. Minitel shows exactly what a successful, otherwise-style network looks like: useful, profitable, and permanently boxed in by the company that owns it. Now follow that thread to the moment that mattered most in our actual history: the decision to release the web's core software for free. In this otherwise version, with commercial telecom and technology companies building the network from day one, instead of an academic physicist working largely on his own initiative, there's no obvious reason any company would give away something this valuable for free. If a hypertext linking system like the one Berners-Lee built gets developed at all, the most likely outcome is a patented, licensed product, sold to the highest bidder, controlled tightly by whichever company owns it. Push that difference forward another 20 or 30 years, and the shape of daily life looks recognizable in outline, but strange in the details. People probably still have some form of instant electronic communication because the economic pressure toward faster information exchange doesn't disappear just because one specific network fails to emerge on schedule. But instead of one open web that anyone can build a page on, browse freely, or start a company through with nothing but a laptop and an idea, the otherwise version of this world likely runs on several competing, closed commercial networks, each requiring separate subscriptions, each controlling exactly what content is allowed inside it, the way cable television companies controlled channels for decades before streaming opened things up. That closed structure changes who gets to participate, too. In our actual history, a huge amount of the Internet's economic and cultural impact came from the fact that almost anyone, anywhere, with basically no capital, could build something and put it in front of the entire world. Remove the open, free, unrestricted foundation, and that door narrows considerably. Building anything meaningful likely requires licensing agreements, corporate partnerships, and far more capital just to get started, meaning far fewer of the individual creators, small businesses, and independent voices that actually built enormous parts of the Internet's culture. In our own timeline, ever get the same opportunity in this otherwise version? Consider how many of the Internet's biggest companies actually started. A search engine built in a garage, a social network coded by a college student in a dorm room, a video platform launched by 3 employees with almost no funding. All of them exist because the underlying network let anyone plug in, publish, and compete on the same open playing field as an established corporation, at least in theory. In a world of separate, closed commercial networks, each one owned and gatekept from day one, that kind of garage-scale disruption becomes far harder to pull off, because there's no neutral, open ground to build on, only someone else's platform, on someone else's terms, with someone else collecting the toll. There's a slower, quieter cost buried in all of this, too. Scientific collaboration in our actual history was transformed by the open exchange the Internet eventually enabled, researchers on opposite sides of the planet sharing data, papers, and results in minutes instead of months. In a world where computer networks stay locked inside separate corporate or national systems, that kind of open collaboration likely develops much more slowly, gated behind whichever institution happens to have access to whichever closed network. Entire fields of research that accelerated specifically because of fast, free information sharing could plausibly be running years, maybe decades, behind where they actually are today. Medicine offers one of the clearest examples of what that delay might actually cost. Genetic sequencing projects, vaccine research, and disease tracking efforts in our own history relied heavily on researchers across dozens of countries, pooling data through shared, open databases in real time. Major outbreaks were tracked, modeled, and responded to using information moving at Internet speed across institutional and national boundaries that used to take months or years to cross through formal academic channels. Slow that exchange down to the pace of licensed, closed corporate networks, each one gated behind separate agreements, and the entire modern pace of coordinated global science, the pace that let researchers respond quickly to emerging health threats in our own timeline, simply doesn't exist in the same form. So maybe the strangest part of this whole otherwise scenario isn't that the Internet fails to exist. It's that some version of connected computers almost certainly still shows up eventually, just built by entirely different hands, for entirely different reasons, governed by entirely different rules. The open, occasionally chaotic, famously ungoverned Internet everyone actually got wasn't the only possible outcome of connecting computers together. It was one specific, almost accidental byproduct of a Cold War panic, and one physicist's decision to give something valuable away for free instead of selling it, It's strange to sit with how much of daily life, the ability to start a business from a bedroom, to publish an idea without anyone's permission, to pull up nearly any piece of human knowledge from a device in your pocket, rests on a handful of people, decades apart, making choices they had no way of knowing would matter this much. A defense researcher solving a problem about surviving nuclear war. A physicist annoyed at losing track of research papers. An institution deciding not to file a patent. None of them were trying to build the specific world we actually live in now. They were just solving the problem directly in front of them, and the world reorganized itself around whatever they happened to build. If the specific openness that defines the internet today wasn't guaranteed, and instead depended on one funding panic and one researcher's choice to skip the patent, it raises an unsettling question worth sitting with. How many other pieces of modern life we assume are simply how technology works were actually one quiet decision away from looking completely different, controlled by completely different hands. That's exactly where we're headed next time on Otherwise, into the technologies that could have been owned by one company instead of everyone. Subscribe and find out who almost controlled it all.